Hi everybody. We're going to talk about how to graph this function here, f of x equals negative 3x squared plus 12 over x minus 2. And what we're going to do is we're going to try and pull it apart as much as possible and look at it again, because that's going to help us with a lot of things. First of all, I'm going to take that negative 3 right there, and I'm going to factor it to the front of this. So if I factor it out of this part, that'll just give me a positive x squared. If I factor it out of this positive 12, then I'll do negative 3 divided by 12, which will give me a negative 4. Okay, over this x minus 2. There's nothing that I can really do with that. I maybe could call it x plus negative 2, but you're actually going to see that that isn't a necessary step here. So then you should see that if you think of this as x squared minus 4, in fact, let me write it that way. This is a difference of squares, so it can be factored into its two parts, the square of the first and the square of the second, or the square root of the first and the square root of the second, added once, subtracted once. And then we still have this x minus 2 on the bottom. So before I start talking about the cancellation that goes on, let me instead make a note. Look down here, and you might look at this and go, okay, there's a vertical asymptote right there. If I do x minus 2 equals 0 and do plus 2 and get x equals 2, it looks like there's a vertical asymptote there. However, because of the cancellation, because of that cancellation, instead of a vertical asymptote there, and actually let me not cross that off because I'm going to need that, but instead of a vertical asymptote, the cancellation tells me that there is a hole at an x value of x equals 2 if I put it back into the original equation. So this is, so there is a hole, or a point discontinuity, they call it. Oh, no, and I don't want to put it into the original. I'm very sorry. I want to put it into the simplified answer. So there's a hole at, for x equals 2, and then you got to calculate the y. Y equals negative 3 times x plus 2, which is this part. That's what's left after this cancellation here, equals, and then we don't want that there, we want a 2 there, so it's negative 3 times 4, which is negative 12. So the hole is at the point 2, negative 12. So not a vertical asymptote, but a hole instead. Okay? So if we're talking about graphing this, and then I'm going to have to go back and look again. Let's see, it was f of x equals negative 3x squared plus 12 over x minus 2. But then we simplified it to, and I'm going to use, well, yeah, I'm going to use y equals equals, and what did we come up with there? Negative 3 times the quantity x plus 2. Negative 3 times quantity x plus 2. With a hole at 2, negative 12. Okay, with a hole at 2, negative 12. So, because of that, all I have to do is graph this line, and it will tell me everything that there is to know about it. I'll put my hole at 2, negative 12. We're going to just call that negative 12. So there's a hole right there, and then I could just build a little table. If I plug in 0, I get out negative 3 times 2, which is negative 6. So there's another point that I can fill in as 0, negative 6, which I'll call right there. And that's an actual point, and it's just a line right there. And of course, then the domain of that graph is would look like this. The notation would look like it goes from negative infinity to 2, not including 2, and that is joined or unioned with 2 to positive infinity. Okay? Because, and we do all that to not include 2. The other way of saying that is that the domain is the x values less than 2, or the x values greater than 2. Another way of saying it is that x cannot equal 2, and those are all the different ways of talking about the domain. The range has the same thing. You could call it from negative infinity, that is from the bottom, the theoretical bottom, all the way up to negative 12, and then that unioned with negative 12 all the way up to infinity, or you could say y cannot equal negative 12. So I hope that that helps with graphing these types of functions and gives you an idea of what you need to do. Thank you very much.